Okay, محاضرتنا اليوم is about geometry of linear programming problems. Okay, so the geometry means we want to see in a geometric way, we want to graph the constraints, okay, and the objective function. We will see how we do that. What do I mean? Let us assume we have a standard form of a linear programming problem. Okay, I want to make sure everything is right. Okay, and this is one of the constraints. Now this is one of the constraints, the ith constraint. AI1, x1, AI2, x2, AIn, xn, and so on, which is written in vector way, this way, and this way. Now, all the n tuples that satisfy this constraint, all of them together, will form a space, and we will call that space a closed half space. Actually, why we say half, why we say closed, will be explained now. This will be clear if we go to this example in 2 dimensions. Okay, now this is a constraint. 2x plus 3y is less than or equal 6. And this is the vector notation. Now, if I rewrite this, the set of all ordered pairs that satisfy, whose coordinates satisfy this equality, inequality. So جميع الأزواج المرتبة x and y, so that 2x plus 3y is less than or equal 6. وين هم هذول؟ وين موجودين؟ هل هم سوا موجودين ولا متناثرين؟ They exist together and they split the xy plane into 2 halves. So if this is the xy, the x plane, the x-axis, and this is the y-axis. Okay. What we will do is we will graph this line. 2x, we will graph 2x plus 3y equals 6. Good? Okay, how we graph it? Take the intercepts, make x equals 0, then we get 3 here. And make y equals 0, then we get 2. Good? Okay, so now draw the line. Okay, let's draw the line. Okay. Now this is the line. Okay. Anyway, good. Okay. Now this line splits the xy plane into 2 halves. Right? We can say 2 halves. It is infinity from here, infinity in here, so we can say 2 halves. Okay? It does not split exactly in the middle, the origin, which you might think it is the middle. There is no middle here. When you say an interval from negative infinity to infinity, where is the center of that interval? There is no center. It has no center. Okay? So any point can be considered as a center. It's not defined actually. So that's why we say it's half. Okay, we want to find where are the points that gives me less than or equal in here. So what I do? Actually, what's happening here? All the ordered pairs at one of the sides of the line are greater than or equal 6. The equation of 2x plus 3y using the coordinates of any ordered pair this way of the line, this way will be greater than or equal 6, and this will be less than or equal 6. How do I know? Check at test point. Choose any point. The easier thing is to choose the origin. It's 2 times 0 plus 3 times 0 is 0, so it is less than 6. So this half space is what we want and what we need. So all the ordered pairs, and this is till infinity from here and here. So in here, what we have the following. 2x plus 3y is less than or equal 6, including the points on the line. That's why we say closed. Now we know why it is half space. Now it is closed because we take the point on the line. Why? Because there is equality. There is equality here, equality, and here again. There is an equality. If there is no quality, we will not take the points on the line, and then we will call it open half space. Okay. Now, also, if you pay attention to what's happening at this side, choose any ordered pair at this side and subtract the coordinates, and you will find always the result will be greater than or equal 6, including the point on the line. So this is how to draw constraints. So closed half space. Good. So either one of these is called the closed half space. So this is a closed half space, this one here, and also this one is a closed half space. Okay? Any one of them would be called a closed half space because it says a constraint, right? Constraint. And the constraint above there is not necessarily to be less than or equal. It can be greater than or equal. This one can be greater than or equal, but still for the definition we will still call it closed half space. Okay, either ways. Okay. Now what if it is an equality? Again, what if we have here equality here? Equality. What we will call it? A line. That's in 2 dimension. What if we have equality in 3 dimension? We call it a plane. It's a plane, right? If we have 3 variables, say 2x plus 3y plus 2z equals 6. This is an equation of the plane. You know it, right? From calculus 2. Okay, what we call it in 2 dimension is line, in 3 dimension is a plane, in 4 dimension, like 2x plus 3y plus 5z minus w equals 10. So the points that satisfy this equation will be called hyperplane. That is a generalization of a line, then it is a plane in 3 dimension. In 4 dimension or 5 or 6 or 7 in higher dimension than 3, the tuples that satisfy an equation, a linear equation, the set of all tuples that satisfy a linear equation is called hyperspace. If I want to make what I am saying clear, let me go here. Go to the slide. This is a review from calculus. If you have ax plus by plus c z abc z equals sum d, what are the points x, y, z? Let me call them 0, not that satisfy this equation or equality, I would call it here. These points form a plane, right? Form a plane. A plane we mean like this is x, y, z. A plane, something going like that. A plane, just some plane. Some plane may be flying over the xy axis. XY plane. Okay? Good. Now, what's about if we have equation of this form? This is linear equation, right? Linear. What if we have a linear equation also, but in 4 dimension? Say a1x1 plus a2x2 plus a2x3, but I will write here like a4x4 equals some constant d. And here in general, actually, let us take it n, where n can be any number. So we will say the tuples the n tubules that satisfy the above equation equality they form the points, the whole points form what is so called a hyperplane. So we cannot imagine planes in 4 dimension, right? But there is a generalization of planes from 3 dimension to 4 dimension to 5 to 6 and so on. How these generalizations come out? They are solutions of linear equations, okay? And we will call the geometric shape of the points that satisfy that equation. We call them hyperplane, a generalization of plane of 3 dimension. Okay? Okay. So let's go back. So we have a line, 2 dimension, we have a line which splitted the space which is here, xy plane. This is the space in 2 halves. Each one of them is called a closed half space. Okay, let's go to 3 dimension. Okay, let's go to 3 dimension. I want to bring this here. Okay, in 3 dimension. So here we want the closed half space H defined by what? So we want H all the 3 tubules, all the points in the space that is ثلاثي x, y, z, so that 4 times x plus 2 times y plus 5 times z is less than or equal 20. Okay, so how we get them? Are they all together or they are shattered? No, they are all together and they make a plane. Sorry, not a plane, a half space. The boundary of that half space is a plane. Okay, so let us try to draw this, and for sure we need to use a drawing from the book. We want to draw the plane actually. How we draw the plane that satisfy the boundary. Okay, so I go here. Okay, this way. Now, how this related to what is above there? Okay, good. Good. So, this picture tells us there's a plane here, a surface. See this surface connecting this line is, okay? Can you imagine with me now? It is kind of, let me say, it is a surface. Okay, you can see it. But this can extend to infinity. It's not only just what is bounded by these lines. So this surface, which is a plane now, it extends in everywhere. So you can imagine now what's happening. So this is a surface. Now, how we draw a surface, a plane in 3 dimension? So what happened, the equation of that plane is this. Here we have it here. It's 4x plus 2y plus 5z equals 20. Good? This is the equation of the plane. Okay. How did we figure out the graph of the plane? It's easy. Sometimes it helps you to take the it is not easy almost to imagine, but it's easy for this one. Take the axes intercepts, which means make, for example, x equals 0 and y equals 0. Then we get here, right? That will give 5z equals 20. So I'm moving from here. So that gives z equals 4. And here we go. Now same thing, make x equals 0 and equals z, and this will give you, using that, 2y equals 20. So y equals 10. Here we go. And for this one, you make y equals 0 equals z, and you get x equals 5. So I got the intersection with the axes. Connect these intercepts, cover them with the plane, and then you get the equation of your plane. Okay? Now, what do we want here? What do we want here? We want to find where are the points that satisfy this inequality. We want the closed half space H. How do we know which side of the plane, the above side or the lower side? The side that comes to us above the screen, or the board, or below, going from the plane to below. How we know that? Simply choose a point from either side and plug it in the equation, in the equality or equation, in the equation, and see whether it gives you less than 20 or more than 20. Choose any point. We would like to choose the origin. It's easier always to choose the origin. If the origin is not in the plane, choose it because computation can make it easy. It makes computation easy. Okay, so if we choose x equals 0, y equals 0, and z equals 0, then definitely this point will satisfy this. So this this closed half space, again we are calling it half space because it splits the three-dimensional space into two halves. So this closed half space is below the plane. We can say it this way, below the plane. So we will call this, we will give it notation. What notation we'll give it? It is now called H. We'll call it H1. Why? Because if we take H2, that will mean the other side. We'll call the other side H2. The other side is reversing the inequality to be greater than or equal instead of less than or equal. So this is also this closed half space is above, we may say it is above the plane. It does not make sense always to say below and above, but this is the way we have to describe our situation. Now, if we introduce a new notation, what do we mean by H hat? H hat is the intersection of H1 and H2, which is the plane. Okay, and we will call it actually the boundary. We give it this color, so it is the plane here, but if we talk in general, we will call it hyperplane. What do I mean in general? I mean hyperplane when more than more than let me say when or with dimension greater than or equal 4, we call it hyperplane. And it is the boundary of what? Of the two closed half spaces. Okay, so the plane is the boundary of the above half space and the lower half space. So it is called boundary. Okay, so this is the boundary. Okay, good. And it is hyperplane. Okay, good. So in general, we only, okay, let me copy that. Because you are seeing a graph in 3 dimension, but I want to emphasize that this terminology goes for any dimension, not only for 3 dimension. So I will emphasize that through saying this. So in a typical constraint in linear programming problem in canonical form is of this form, right? It is equality. Okay, so when we had standard form, the constraint was half space, صح? Half space, because it was less than or equal. The constraint is half space. But in canonical form, the constraint is equality, equal only. So it is the plane itself, all the hyperplane. Okay, so when we are in canonical form, so we have this inequality, okay, and then the points that satisfy it will be called hyperplanes. Okay, now if this equation were an equality, namely, okay, now هذه في حالة equality هنا. We are working here talking about when we have equality and inequality. What if we have an inequality? What we get? So inequality, okay, the set of points satisfying the inequality would be closed half space, okay, هذا اللي قلته قبل شوي, and the hyperplane is the boundary of the half space. هذا في أي dimension, okay, هذا اللي أنا عملته قبل شوية in 3 dimension. Okay, good. And actually I have just found myself explained what I wanted to copy, يعني الأشياء اللي أنا كنت مجهزها عشان أعملها copy هنا. واشرح لكم إياها، شرحت لكم إياها سلفا. هذا هو، هذا الكلام اللي فوق كله هو اللي أنا حكيته، اللي هو هنا، يعني هذا كله هيك بيجي سوا، صغير ما تشوفه الآن، ها أرجع كبرها، هذا الكلام كله يجي هون. جميل؟ يعني كان بإمكاني أستبدل هذا الكلام وأجعله هذا هون مرة أخرى. إيش هو؟ أوكي، هذه هي again. Okay, so no need to say more about this. لكن to emphasize, this goes for n-dimensional. So we will just go this way, copy, paste, and now this thing is repeated about the h1, h2, but in Rn. So what we are doing here, we introducing things in 2-dimensional or in 3-dimensional because we can draw them, we can imagine such cases, but in more dimension we cannot. So uh, what we have already obtained from 2 and 3 dimension, we can take it to higher dimension without graphing. This is what I'm saying. Now the hyperplane H in Rn, it divides the Rn into two closed half spaces. First one, H1, all points, that means all ordered n-tubules, or all ordered n-tubules, such that A transpose, there's an X missing here. I think this is missing in the book, and an X missing here. Interesting. This is missed in the book. Yes, it is missed in the book, or maybe the soft copy I have here. So we need to fix that, such that A transpose time X, A transpose time B is greater than. Okay, so if I go back here, that means A1x1 plus all the way ANXN is greater than or equal. I need to use here, it is only one. We are speaking about only one constraint. So we will use A1. We will not use AI1x1 plus AI2x2 plus and so on. Why? Because we use this I here when we have more than one constraint. صح؟ لما يكون عندنا 3 2 أو 3 أو 4 constraints كنا نسمي الأول الفيرست the ith one and so on. Okay؟ مثل ما بدأنا المحاضرة. لكن هنا الآن إيش إحنا بنعمل؟ إيش الفكرة بتاعت المحاضرة أصلاً؟ أحد أفكارها هو الانتقال من 2 3 dimension to higher dimension، والفكرة الأخرى هي إن نشتغل مع constraint واحد وبعدين نعمم على مجموعة من constraints. شفتوا هذا هنا؟ You see this? Here I assumed I have one of the constraints. Now I am working with only one of the constraints. بدنا نعرف كيف نتعامل مع constraint واحد، بعدين نصير نتعامل مع مجموعة constraints سوا. طبيعي. If I have one constraint, then I have two closed half spaces. If I have two constraints, this one have a closed half space, the required, and this one has the required. So I have to take the intersection. Okay, let me see there. إذا كان عندنا constraint واحد فهو بيقسم السبيس إلى نصفين. constraint معناه الفاريبل لازم يحققوا هذا الكونسترينت. إذا كان عندنا two constraints معناه الفاريبل لازم يحققوا two constraints. الكونسترينت الأول بيعطينا plane بيقسم السبيس ل two halves، والكونسترينت الآخر بيعطينا another plane يقسم السبيس ل two halves. الأول كان فيه close half space اللي بيحققه، والآخر كان فيه close half space اللي بيحققه، والvariables لازم يكونوا موجودين فيهم الاثنين. The variables must exist in both of these closed half spaces. So the variables must satisfy their intersection. So this is the idea. We are working with one constraint. After we understand that, we work with each constraint and take the intersection of the closed half spaces that are coming from these constraints. Okay, so this is the idea. Now we are still working with one constraint. Go ahead. Somebody wants to ask a question? Somebody close the microphone, please. Okay. So this is greater than or equal B. So we have one constraint here. And this is the same thing to xn, so that okay, I must copy this. This is less than or equal. So this is h1, greater than or equal is h2. Now their intersection gives the boundary. Okay, this goes for multi-dimension. Okay, this is for only one constraint. Okay, الآن let's go take examples in 2 dimension and 3 dimension and draw with more than one constraint, and draw the required area which for which the variables must satisfy the required area of the whole constraints together. Okay, شوفوا هذا مثلا. Sketch the visible solutions satisfying the set of inequalities. So remember, the visible solution means all the ordered pairs that satisfy these, but not necessarily they will maximize the objective function yet. One of them will maximize it. Okay. So let us draw that. X-axis. Actually, is it ready? Is it ready from the book? Okay. No, let's do it by our own. Okay. This is the x-axis. Now the y-axis. Okay, now what we will do, we want to draw the two lines. Let us first draw this line 2x plus 3y equals 6. Make x equals 0, we get 3. Make y equals 0, we get 2. So this line is can be drawn. Oops, it is here. Okay, good. And now let us draw the required half space of it. The required half space, we have seen it before, it is less than or equal. So take 1 point, 0, 0, satisfy, and then we go and shade, highlight this half space, close half space. Done? Okay. Let's go and do the same thing for this line. This line, if we take the x-intercept, is 2y equals 4. So let me go back and just write, this was 2x plus 3y equals 6. Now I will draw minus 2x plus 2y equals 4. Take the y-intercept is 2. Take the x-intercept is negative 4. Right? Yes. Negative 4. And let us draw the line. Okay, good. Now, which side is the required one for the constraints? How do we know? We choose a point to check. Choose again 0, 0 here. If we substitute, we get 0 plus 0. So it is the one. So the required half space is that. All of this here, all the way. Now you notice this area here satisfies both. All the ordered pairs here satisfy both constraints. No, I missed something. I missed something. What is it? Okay, what was it? I forgot to keep an eye on these. Okay, so this area is the one satisfy these constraints. Agree? Agree?
Excuse me, Doctor.
Go ahead.
There is a mistake in the first line.
Yes,
The
yes,
intersection of of y-axis must be 2, 0. I mean 0, 2, and
Yes, thank you. Yes, so keep saying this shall be 2, right?
yes,
Thank you. And that one shall be 3.
yes.
Thank you. So the scales now are not good, so the line shall be more like this, but thank you for the fixing, good. So this is now again, this is in yellow, the required area. تمام؟ اوكي الان اذا بدي اقفز لقدام شويه اوكي ايش انا اقول هنا؟ الفاريبلز اللي راح مسموح لي استعملهم حتى اعمل مينيمايزيشن وماكسمايزيشن، النقاط الازواج المرتبه لازم يكونوا من جوا هون فقط، مو مسموح يكونوا من برا، لانه عندي كونسترينتس، عندي عدد الموظفين على اكثر هيك، عدد الساعات اللي بدي اشغل فيها الاله المعينه هيك، هذه هي الكونسترينتس. اوكي الان according to this constraint I want to achieve a maximum or a minimum. minimum maximum ايش؟ اوكي هذه هي الفكره. x و y بيدخلوا جوا variable اللي هو جوا function اللي هو الاوبجكتيف function. فمثلا الاوبجكتيف function بيكون ايش؟ بيكون z تساوي ax plus by، واحنا بدنا ماكسيموم اكبر قيمه له، لكن النقاط اللي نعوضها الاكس واي من جوا المنطقه الصفراء. كويس؟ الان لكن هذا معادله البلين اصلا z equal ax y. الان فلو دخلنا فيكتور اكسس جديد اللي هو z عمودي عليهم، فبيكون في عندي فوق بلين ماشي بوم، فبصير السؤال مين اعلى نقطه في البلين، بس يكون القاعده بتاعتها صوره، هي صوره من نقطه زوج مرتب جاي من المنطقه الصفراء هاي. اوكي I hope you could imagine what I'm saying. Okay, now let's see the very last thing for today's lecture. We will not finish the whole section today, we will take this part. Just a little thing is left, which is the convex sets. We will see it next class inshallah. Okay, الآن consider the linear programming problem. Minimize this objective function under these constraints. اوكي ايش اللي بصير؟ الآن شايفين الرسمة هذه في الكتاب؟ أنا أحاول أساعدك إنك تفهمها. هو ليس من السهل to draw the plane z equal 4x plus 3y. كيف بده يبين لك اياها؟ إذا رسم البلين بيغطي على اللي وراه وبطل تشوف. صح؟ فهو عمل الخطوط هذه الداشت so that you imagine the plane. How? The plane بيمر منهم كلهم. تمام؟ لا no. What I'm saying, let me make sure what I'm saying. Okay, z equal 9. I have a plane z equal 9 and a lot of points will give me z equal 9, and that means okay, please help me. ساعدوني كيف اتخيل ايش قاعد بيعمل الرسمة هذه. انا كان عندي في بالي تخيل معين، تراجعت عنه الان. اوكي الفكرة هنا let me try to explain what's happening. Let's say this is x, this is y. Oh, I can draw lines without any problem. Z. Okay, now we have plane flying somewhere, plane going somewhere like this. Okay, so let me draw it this way. We have a plane going somewhere. I wish I did it in blue. Okay, so there is a plane flying somewhere. it contains states for infinity. Okay. Okay, good. Now, good. I like this one, but let me make it bigger. I want to make the plane bigger because I will draw more lines, I believe. Okay. Okay. Maybe my figure here is better than the one in the book. اوكي الان عندك اكس واي وزي اكس خليني اقول اكس واي جاي لبرا لعندنا والزي هو الطالع هنا وفي عندي بلين هيك طاير. تمام. اوكي سيبوكم من البلين الان خلينا نروح على الكونسترينت. خلينا نروح على هذا الكونسترينت. اوكي انا بدي استعمل الالوان بشكل كويس. خلينا نروح على هذا الكونسترينت. هذا نرسمه. وين الخط بيكون؟ واضح انه راح يكون هذا هون 4 مظبوط لانه تقاطع عند الاربعات. ايوه رسمناه. وين الهاف كلوزد السبيس المطلوب في اي جهة؟ في هذه الجهة صح؟ انا ما راح اخذ السالب. خلاص راح اضلل فقط الموجب. يعني انا ايش اقصد؟ لو عوضنا صفر هنا فبحقق لنا المعادله. اذا هذه هي المكان المطلوب. هو الهاف سبيس بياخذه كله ماشي اللي هو مع الاكس واي بلين. هذا الرسمه ماشيه مش طايره مع الزي. جميل. هذه رايحه مع الاكس واي بلين فظبط الرسمه بحيث نظن انها اوكي. الان نرسم اللاين الاخر. اعطوني اللاين الاخر. هذا التقاطع هو 3 مع اكس 3 و5 مع واي 5. وهذا هو اللاين. تمام. اوكي وبدنا 5x plus 3y less than or equal to 15. Choose a test point which is the 0. So we will take this side. We are in the xy plane. So we did not take this part. It satisfies the first inequality, but we will not take it. And this side here, this region, satisfies the second inequality, but we will not take it because we only will take the one that satisfies both of them. The first constraint inequality and the second constraint. And this is in yellow, this side. Good. Okay. ممتاز. تخيلتوا الآن الأزواج المرتبة ordered pairs I am allowed to use is from this yellow region. Now go to the plane. The plane is flying somewhere. ايش هي المينيموم ماكسيموم ولا مينيموم؟ الماكسيموم هو المينيموم اللي بيتخذها البلين لكن بيكون هي الصورة جاية من أحد الأزواج المرتبة اللي في المنطقة الصفراء. جميل؟ فالآن أحاول أتخيل يعني هذه البلين عندنا طاير فوق. فإذا شفنا شكل الرسمة هذه كيف بده يكون صورتها ربما تكون عاملة هيك الشكل بتاعها. هذا الآن طاير وين؟ مع البلين فوق. جميل. أعطيه لون أزرق. فبيكون السؤال وين الماكسيموم ممكن يحدث؟ حسب البلين ما هو مائل أو غير. وين ممكن الماكسيمايزيشن يحدث؟ اوكي هذه هي اللينير بروجرامينج بروبلم. مبروك الآن فهمتوها بشكل أسهل. بس هذا في 3 dimension في 3 variables مش هيك؟ راح نكون مطلوب منا نحلها في المالتي فاريبلز. اوكي الآن هذه رسمتي وهذه رسمة الكتاب حتى يوصل لك الفكرة. المنطقة الصفراء اللي أنا راسمها هناك هي هي. الآن والداشت لاينز هو قصد يعطيك imagination للبلين اللي فوق. الآن وراح يحدث الماكسيمايزيشن اللي احنا بنبحث عنه انه يكون هنا رغم انه الرسمة بتاعتي بتوحي لك بأنه الماكسمايزيشن إنه الرسمة عاملة هيك، وبالتالي هذا مش مينيموم. إنه يمكن إنه البلين لازم عملته هيك أصلا، هذا مجرد رسمة. Okay, anybody has any question? This is enough for today.